Okay, today we discuss about electrostatics. So first of all, what is electrostatics? Electrostatics, this is nothing but study of charges which are at rest. So that is why we are using the term called statics. Static means rest, which we will study in our mechanics. So electrostatics, the meaning of electrostatics is nothing but the study of charges which are at rest. So what does it mean? It means, for example, I am having an electron. Electron will be having charge of 1.6 into 10 power minus 19 coulombs. Okay, where coulomb is nothing but a unit of charge. And now, if the charge is at rest, that means if charge is not moving, and I need to find the force acting on one test charge plus one q or whatever it is. And whenever I am telling about the positive test charge now, then that means I am mentioning about a positive charge which is nothing but 1 coulomb. Okay, so if I bring 1 coulomb of charge here by placing electron or whatever the charge here, let us assume that here there is a charge of q dash. If you assume that this is q, then I need to find the force acting on this 1 coulomb of charge, test charge, and then I need to find the acceleration of this charge if q is constant, if q is stationary. So this is nothing but our electrostatics. So this is all nothing but study about charges which are at rest. So first of all, let's dive into what are these charges and how to charge a body. So in earlier days, what happened is, what we do is, we just consider a silk cloth, and just rub it with a rod. Just take a rod, just rub these two things. So what happens, after some time, you will find some charge on these two objects. So there are two ways of charging. One is nothing but charging by friction. And another one is nothing but charging by induction. So let's try to understand these two concepts very clearly. So what is charging by friction? Let's try to understand this by a very familiar example. Let's take a pen and you just rub it with your hair. Then what happens? After some time, you just take the pen and bring the pen near a paper, piece of papers. Then what happens? Then it will start attracting. So why? Because the pen got charged, and because of this charge, these two particles are attracting. So the basic thing is, like charges always repel. Like charges always repel, and unlike charges always attract. And unlike charges, so this is the concept. So now let's try to understand what is this charging by induction. So how can I charge by induction? What is induction? So we'll try to understand this concept. So charging by induction is nothing but we are inducing charge. Something like I am inducing the, if I am any expert in doctor, then what I will do, if I am a hypnotist, then I will induce some sleep in you by doing something like look at these circles, something like that. What I am doing, I am just inducing. There is no sleep in my brain actually. But what I am doing, I am bringing the sleep. So that is nothing but induction. So I can also induce charge, and that is nothing but charge induction. For example, let us consider a place Q, and there is a metal which is separated by some distance. Distance is not large, and if this sphere, if this is a metallic sphere, then what happens? Since this is positive charge, all negative charges on the sphere, because since it is a metallic sphere means it will be having more number of free electrons. So since this is positive charge, all negative charges get attracted this side, and positive charge will be along this side. Now what I am doing, I am just connecting this sphere to the earth by wire. So this is nothing but earthing. So whenever I do earthing, then what happens here is the whole positive charge gets transferred to the earth, and our final scenario will look like this. Here it will be plus q, and here it will be charge, and it will be left with only negative charge. Why? Because Earth is a very good conductor, actually it can take as much as positive charge and it also give as much as negative charge. We'll discuss about our next case. So here the negative charge is induced. Here the charge is induced. So this is nothing but charging by induction. So let's look at another similar kind of case in different situation. For example, let's consider negative charge this time. There is a negative charge and there is a sphere. And what happens? The whole positive charge gets attracted to left side and the negative charge will accumulate on the right side. So whenever I connect this to the earth, then what happens? If there is a negative charge here, and then the sphere will be induced with positive charge, because the whole negative charge gets transferred to the earth. So that means this is nothing but charging by induction. So actually initially there is no charge on the sphere. At this moment also there is no charge because there is positive and negative. The total it is neutralized. But whenever I am just connecting the thing and I just bring in another charge, then I am just inducing some charge on the sphere without actually being in physical contact. So this is nothing but induction. So now let's try to understand Coulomb's law. This is very important law. Why? Because this states the force of attraction between two charges. So what does this Coulomb's law states? Actually this is based upon experimental values. So what happened is, they just bought one charge Q, which is having the charge Q. They bought a test charge because they don't have any dimensions. They just bought another charge. This is Q1 and this is Q2. Okay. Now they observe the force acting on the charge Q1 because of Q2. Why? Because there is a charge Q2. This is Q1. These two are positive charges. So there will be force of repulsion. The force of repulsion on Q1 will be in this direction. Similarly, the force of repulsion on Q2 will be towards right. So what they observe is, if F is a force acting on Q1 due to Q2 equivalents to force acting on Q2 due to Q1. And what is the magnitude of F? What they observed is, the distance between these two charges is R. Then force is directly proportional to 1 by R square. I can write force is inversely proportional to 1 by R square. And also force is directly proportional to product of these two charges, that is nothing but Q1 into Q2. So that means they say force is equals to K into Q1 Q2 by R square, where K is nothing but proportionality constant. Actually this is nothing but actually K tends to be 1 by 4 pi epsilon. This is for vacuum, not for all objects. For each and every medium it will be some value. This epsilon, this is for vacuum. If I write K is equals to 1 by 4 pi into epsilon without writing O here, then it is for some other space. It may be water or any other space. So it depends upon the space. In general we consider about the vacuum. So that's why we are writing it as epsilon. So this is the force of attraction. But here the thing is, first of all force is vector quantity. So I can't just give force is equals to K Q1 Q2 by R square. It should be having some direction, right? Because I should mention force is acting on this particle either this direction or this direction or this direction or this direction. Because I need to mention in which direction it is acting. So the complete Coulomb's law, the exact Coulomb's law can be stated as force on any charge is equals to K into Q1 into Q2 by R square into R21 cap. If force on 2 by 1. So let's try to understand this equation. So what does this equation says? This equation says that force on second charge. So this is nothing but force on Q2 due to Q1. That means force on this charge Q2 because of the charge Q1 here will be equivalent to K into product of these two charges by R square. R is nothing but distance. And what is R21? This is nothing but unit vector of position vector of 2 from one respective. So let's try to understand this term thoroughly. If there is charge Q1, if there is charge Q2, so what is R1 R1 bar is this. So this is nothing but position vector of a charge Q1. Position vector is nothing but any vector which is joined from the origin to the given point. So this is R1 bar and this is R2 bar. Now if I join these two, Q1 and Q2, and if I name this vector from the triangle of addition, I can write let this be x bar. Then R1 bar plus x bar is equals to R2 bar. So x bar is nothing but R2 bar minus R1 bar, right? So this is nothing but I can write it as R21 bar because R21 bar is nothing but R2 bar minus R1 bar. So that is nothing but the direction. That is nothing but this vector. But I am just telling this is a unit vector. So I can write R21 bar is equals to I can write unit vector as mod R into R cap. So from this I can get mod, this is mod R21 into R21 cap. So from this I can get R21, the unit vector along R21 is equals to mod R21 bar by R21 bar. So substituting this in this equation, then we will be getting force is equals to K into Q1 into Q2 into R21 bar. Yeah, actually this is not magnitude. Yeah, this is R21 bar by R21 bar whole cube. So this is nothing but the complete equation of Coulomb's law. So this is the exact equation. This is a vector equation. So this is very important. So there are many questions which are based upon this equation. So this is a very important equation which we come across in our electrostatics. Now let's try to deal with one question. The question is very simple. So let's try to understand this question. This is very interesting question. There is a rod. The length of the rod is equals to L. There is a charge, point charge, which is having charge Q1. And the length of the rod, this rod is having charge of Q2. Now this end is at a distance of A from Q1. Now the question is, what is the force between Q1 and Q2? So the question is force between Q1 and Q2. So let's try to solve this question. First of all, I would like to solve this question using our Coulomb's law. So F is equals to K into Q1 into Q2 by R square. Then I will be getting F is equals to K into Q1 into Q2 by. What is this R? What is this? What should be the value of R? Should I take the value of R as A, either it is A or either it is L? What is R? Because charge is at here. If it is at this point, if I consider some charge at this point, the distance from this point to this charge will be A. If I consider this point, the distance is A plus L, right? So R is not constant. R is keep on changing. So that's why we can't do this question using this way. So we need to solve this question using different way. Let's try to understand how to solve this question. So first of all, Coulomb's law is applicable only for point charges. So actually there is no point charge here because this is not a point charge. Point charge is nothing but a charge, just a point. That means it won't have any dimensions and something like just these two are considered as point charges. But this is not a point charge. So how do we solve this question? So that's why we use the concept of integration and differentiation here. So what I am doing is I am trying to chop this given length into infinite pieces. So this is one piece, this is one piece, this is one piece. Now I can consider this piece as one point charge. I can consider small piece, small. Actually, this is infinite small. You should say this infinite small piece as a point charge. And then I can apply Coulomb's law. apply Coulomb's law, then we'll be getting the answer. So let's try to do this. So what I'm doing, this is my charge Q. This is my charge Q. So I'm just considering a small piece at a distance of x from the charge Q1. If this is Q1, at a distance of x, there is a charge, small charge. So what is the thickness of this small charge? This will be dx, because this is infinite small. Okay. Now the charge on this small element dx will be equal to dq. Now q is a charge for length L. Now what is the charge for length dx? That is nothing but q by L into dx. So this is nothing but dq. So this is the value of dq. So what is the force between dq and q1? I can apply Coulomb's law here, because these two are point charges. dq and q1 are point charges. So now I can apply Coulomb's law, which states that F is equals to k into q1 into dq by what is the distance from point charge to q1? That is nothing but x. So x square. So this is the force. Now I need to. This is the force due to this small element dq. So this is nothing but small force df. So I can write df is equals to kq1 dq by x square. So that is nothing but, let's try to just erasing this. So now by applying this, I can write df is equals to k into q1 into what is dq, but dq is nothing but q into dx by dl, q into dx by L into x square. So we are having all x square term also. So this is our equation for small force. If I want the whole force, what I need to do? I need to integrate. So if I integrate on both sides, then the total force from it will become 0 to f. So f will be, but x is varying from a to a plus l. Why? Because x value starts from here, this point. So that means this distance is equal to a, and the maximum value of x can be at this point. That is nothing but a plus l. So the limits of x moving from a to a plus l. So f is equals to integral a to a plus l k into q1 q dx by l into x square. So k is constant, q1 is constant, q is constant, l is constant. So I can bring constants out of the integration. So it will become k into q1 q by l into integral a to a plus l dx by x square. But I know integral of dx. What is integral of dx? Integral of dx is nothing but integral dx is nothing but x power minus 2. Integral x power minus 2 dx a to a plus l. But integral x power minus 2 is nothing but x power minus 2 plus 1 by minus 2 plus 1. By applying limits a to a plus l and writing it as k q1q by l. So if I apply limits, then I will be getting f is equals to, from this I will be getting f is equals to k into q1 q by l into, yeah, there is minus 1 here, and also by considering upper limits, x power minus 2 1 by x 1 by a plus l minus 1 by a. This is our answer. So let's try to simplify this. K q1 q by l into 1 by a minus 1 by a plus l. So it will become f is equals to k q1 q by l into a plus l into a plus l minus a, that is nothing but l. So this l gets cancelled. So the total force between these two charges will become k into q1 q by a into a plus l. See? So this is the total force. Not f is equals to k q1 by r square. But we need to consider 2 point charges and then we need to solve this question. So this is the end of the lecture. We will continue in our next class.